you think about it, if the definition of biology is the study of life, then the definition of astrobiology would be the study of life in space. But is that all there really is to it? To learn more about astrobiology, I reached out to Dr. Rachel Harris. She's a NASA Postdoctoral Management Program Fellow in the Astrobiology Program, Planetary Science Division, at NASA headquarters in Washington, D.C. Apparently, there's a difference between astrobiology and space biology.
Astrobiology is the exploration of the origin, distribution, and future of life in the universe. So it's very broad, very interdisciplinary. Meanwhile, space biology is specifically the study of how terrestrial life, so life from Earth, is able to respond to and adapt to life in space. So when you think of, your tardigrades that are, taken up to the ISS and manipulated and trying to see how they're responding to, cosmic radiation, for example, any kind of biology work that's being done on the ISS, that's where space biology is really defined. And so, but there is an overlap with astrobiology. I mean, my area of expertise it kind of hinges into the realm of space biology because my research looks into how terrestrial microbes, so methane producing microbes like methanogens, how they respond to, for example, Mars-like conditions. And so they are distinct fields, but they are not without their overlaps. And so as we continue to venture out beyond this planet and we start thinking about, even like the search for life on other worlds, a lot of our understanding about the habitability of these worlds is presently predicated on what we call analog studies that we conduct here on Earth. So we take a terrestrial microorganism, we subject it to conditions that would be experienced on another planet or on another world, and we see how that organism responds to it, and if it survives and if it grows. And so it's kind of where like extremophile microbiology intersects with space biology. It's all very closely related.
A good example of astrobiology is the OSIRIS-REx mission. OSIRIS-REx stands for Origins, Spectral Interpretation, Resource Identification, Security Regolith Explorer. It launched on September 8, 2016 from Cape Canaveral, Florida, and the primary goal was to collect a sample of rocks and dust from the surface of Bennu and return it to Earth for analysis. OSIRIS-REx arrived at Bennu on December 3, 2018, and began a detailed survey of the asteroid. On October 20, 2020, the spacecraft successfully collected a sample from Bennu's surface using its touch-and-go sample acquisition mechanism, or TAG-SAM. The sample capsule was delivered to Earth on September 24, 2023, landing at the Utah Test and Training Range, where the samples were analyzed and discoveries about life in space were made.
Huge discovery, major discovery that, all 5 nucleobases that are used by life, so that's A, T, C, G, and U, and 14 of the 20 amino acids used by life were found in grains from asteroid Bennu. I mean, I feel like that just goes to show that the ingredients for life are widely distributed across the cosmos, and we are only just beginning to understand. We're only just beginning to understand how, like, the prebiotic chemistry that can lead to life and just how ubiquitous it is. And so I think it just also really speaks to the value of sample return and just how much we can learn by bringing samples back to Earth. And I think that, if a cold, icy, dark body like Bennu has the ingredients for life, then I can only imagine what we're going to find bringing samples back from Mars, or, going beyond further into the outer solar system. I mean, I'm really excited about Europa Clipper and what it could find.
Now, just because we have the ingredients for life out in the universe, does that necessarily mean that they can be baked into life? Just because you have the ingredients and a recipe, does that necessarily mean that it's possible for the right conditions to exist
Oh,
to
that's a
make
great
a
question.
life?
Yeah. I mean, I think to continue that analogy, I think this is especially relevant in baking. You can have a recipe and an ingredients list, but the order in which you bring those ingredients together and you combine them and you introduce heat or how long something goes for, or even just, something completely outside your control that could be influencing like the entire process. Like you get a phone call in the middle of mixing something and you walk away and you forget that you've left something on the counter and suddenly it's like overproofed. I think in a very similar way, um, even if the building blocks of life are ubiquitous in the universe, it's very clear from our understanding of life here on Earth that, I mean, all life on Earth shares a common ancestor, last universal common ancestor. That doesn't necessarily mean that that was the only life that was ever on ancient Earth. Life could have started and stopped many times. Early history of the solar system is marked by large impacts very frequently. That life just had to deal with, um, you know, extinction level events on a pretty regular basis. And so there is this stochasticity or this randomness that absolutely contributes to whether or not something that is prebiotic that can become life and then sustain itself long enough to be able to then proliferate and survive.
As a kid, I wanted to search for life in the universe too. And what we had was SETI at home, where Berkeley would use users' computers in order to process the data that they collected. While SETI is in hibernation right now, there are other ways that you can get involved if you're interested in astrobiology.
Yeah, so the Citizen Scientist Seed Funding Program, that is a great way to have citizen science projects. So one thing that we are soliciting right now for the NASA Decadal Astrobiology Research and Exploration Strategy, or NASA DARES, um, are ways for the public to get involved in astrobiology, science creation. And so NASA has research programs, Citizen Science Seed Funding Program being one of them, which is a way for science investigators to um, work collaboratively with the public for pretty much like large data collection.
Astrobiology, as well as space biology, show us how both human and extraterrestrial life can survive and even thrive in the vastness of space. And while we have no evidence of intelligent life yet, asteroid Bennu has shown us the building blocks are out there. All we have to do is keep looking.
We choose to do the exploration of space for peaceful purposes, and so keeping that in mind, the peaceful exploration of space requires us to be mindful of the potential denizens of other worlds. And so it's 100% a very important philosophical and societal consideration that I think requires input from many important stakeholders, not just scientists. It's really, I think it's really everyone's prerogative to want to care about this.
Thanks for watching. If you like this video, smash that like button. Click that subscribe button for more content from Texas Dark Skies, and ding that notification bell to get notifications when new videos are posted. Take care of yourselves, and in the words of my favorite personal astrophysicist, keep looking up.